Assalamu alaikum wa rahmatullahi wa barakatuh. So let's just continue with binomial distribution. This is going to be the second part. Now, look. Oh wait, what did I just do? So part two, okay? Now look, now we're going to learn the formula for, binomial distribution. And that is Px is equal to R. I'm going to explain what these symbols mean in a second, right? NCR, PRQ, N minus R. Now, you already know what P and Q is, right? P is the probability for success, Q is the probability for failure, N is the total number of times, the experiment is being repeated, like we said 10 times or 20 times or anything like that, okay? Now, what is R? This is the desired number of, of successes, right? Now, instead of shooting bullets in the air like I normally do, I think it would be better if I were to just write a question. Now, look, every time you see a binomial distribution question, you must make sure it is a binomial distribution question by, checking all of these conditions, right? There's a fourth one as well, by the way, just so that you don't forget. So let's say, again, let's do Sarah this time, okay? Sarah throws a dice, let's say 10 times, right? Now look, x, this thing, x, is what we call the random variable. And the random variable is something we also learned about in the, um, you know, probability distribution tables, right? Now look, Sarah throws a dice 10 times. X, which is the random variable, denotes how many times does the, dice land on, four. Let's say this, right? Now, the first part here is find the probability that dice lands on four, uh, three times, right? So what they're asking us here to find is that Sarah is going to throw a dice 10 times, right? She's going to throw a dice 10 times. So as she's throwing the dice, three times what is the probability that out of the 10 times, three times she's going to receive, or three times the dice is going to land on a four? What is the probability for that? Now, before we can do anything, before we can start applying any kind of formula, we need to make sure that this is a binomial distribution. So let's say you're sitting is an, sorry, let's say you're sitting in an exam and this question just, appears right in your very front, right? The moment you look at it, what is the very first question that must, rise up in your head? And that is going to be, is this a binomial distribution question? How do you know? Let's start checking by the conditions. Is the first condition satisfied? It is a repeated experiment. Yes, Sarah is throwing the dice 10 times, or it is a repeated experiment where the number of repetitions is known, n. So if we start writing the data down, we know n is equal to 10. We have 10. We have n. That is 10. Discrete outcomes, yes, this condition is also true. The reason being a dice can have 1, 2, 3, 4, 5, 6, right? I was just trying to be fast for now, but in an exam, they don't normally say a dice. They normally tell you that it is a fair-sided and it is a fair and how many sided dice, right? This time, we're just using a simple fair six-sided dice, okay? So our second condition is also satisfied, discrete outcomes. Now, is there a, is there a concept of success and failure. Yes, there is. You know how? Sarah is throwing a dice 10 times. We have to find the probability that the dice is going to land on a 4. So the probability, so look, what is the success? The success is dice landing on a 4, right? That is the success. So obviously the failure would be not 4, you know? So the probability for success, which is P, is going to be 1 over 6, right? I'm not going to keep on explaining why it's 1 over 6 because, I mean, if you don't understand that, then you should go and watch the very first probability video. Now, look, P is equal to 1 over 6. That's one thing. What is Q going to be? It would be 1 minus 1 over 6, right? So that would be 5 over 6. Now, I would rather not write this. Let's just do this. 5 over 6. Now, look, we have got N, we have got P, we have got Q. The first equation, the first condition is being satisfied. The second condition is being satisfied. The third condition has finally been satisfied. Can I finally say that this is can I now safely say, securely say, peacefully say that this is a binomial distribution? No, I can't. Why? Because we still haven't checked the fourth one. Are P, Q, and N constants? Yes, they are constant. Because regardless of how many times you're going to throw a dice, the probability for the dice landing on a 4 is going to still remain the same, right? The P does not change. And if the P doesn't change, then Q literally depends on P. If P doesn't change, then Q doesn't change, and N isn't changing. Why? Because they've told us that she's going to be throwing the dice 10 times, right? Now, what is this 3? This 3 is the R that we are going to use in the question. And yes, we now finally know that this is a binomial distribution question. This is the R, right? So R is actually how many times do you want the event to happen in the experiment? So you know it's going to happen 10 times. How many times do you want the success to happen? That would be our R, right? So this is how we're going to solve it. P x is equal to 3, right, is equal to NCR. What is N? 10. C and R is 3, right? That's one thing. Now what is C? This is actually combination. You're going to learn more about it, you know, in when we start learning about combinations and permutations. But for now, this is combination. This is, you're just going to find it on your calculator, okay? NCR, and then what do you have? PR, right? So the probability of success is 1 over 6, times, or not times, raised to the power of R, right? Or raised to R. That would be 3, and then 5 over 6, Q, N minus R, 10 minus 3, right? This shall be your answer. Again, I don't have my calculator on me. I would have calculated it right here for you, but I'm not going to do it. Why? Because, I mean, I want you to do it yourself. So that is one thing. Um, this is how you're going to solve it. This is going to be your answer. So the very first thing you do is make sure the question that you're looking at is actually a binomial distribution question. And once you're done with that, you just apply this formula. That is NCR, PR, and Q, N minus R. This is just it, right? And nothing more than that. Now, what is C actually? You know what? You can give, let's just not talk about it right now because we're just going to be learning more about it in the permutations and combinations chapter. So let's just not do it right now. Okay. Let me check how much time has elapsed? 8 minutes. I think we can do another question. Now look, let's do another one. Let's say that now Amanda, this time wait, Amanda is flipping a fair. You know what? Let's do it different this time. Is flipping an unfair coin 15 times. Dude, 15 times, right? Now look, the probability of her obtaining a head is 0.67, right? 0.67. That was the meme. Okay. Okay, never mind. I wasn't trying to write it as a meme. It just kind of just, fell out in the flow, slipped in the flow. So the probability of her obtaining a head is 0.67, right? Find the probability of her obtaining a heads 5 times, right? So out of the 15 times she's going to, flip the dice, flip the coin, she must obtain a heads 5 times, right? Now, I told you what is a fair coin. A fair coin or anything that is fair actually means that the probability for all of its outcomes is going to be the same. You know, well, for example, for a six-sided fair dice, the probability of the dice rolling on a one is 1/6. The probability of a dice rolling on a two is again 1/6. 1/6 for three, 1/6 for four, five, and six. Right. So for all of the individual outcomes, the probabilities are equal. They're the same. Right. This is the case with a coin, a fair coin, which has only got a head and a tails. Right. Or they also call it a biased. If it's unfair, you can also call it biased, right? Because I've seen this word in the exams, in the past papers. So, biased coin 15 times. So, there are only two outcomes. She can either obtain a head or she can either obtain a tails, right? So, the probability for head and tails both should be the same had it been a fair coin, but it's not a fair coin. It's a biased coin or an unfair coin. So, the probability for head is 0.67. Then what would be the probability for tails? As there are only two outcomes and the total probability is always equal to 1, right? You can say that the probability for obtaining a tails is going to be 1 minus 0.67. Right? It's going to be 1. Or in other words, now look, find the probability of her obtaining a heads 5 times, right? So what is the success in here? The success or P in this case would be 0.67, right? They already gave this to you. And the probability for Q, the failure or tails would be again 1 minus 0.67, right? Let me fetch my calculator. Yeah, I'm back. Now look. So that should be 1 minus 0.67 gives you a 0.33, right? So it's just going to be 0.33. Now, okay, I made a mistake. I should have said, okay, guys, I've written a question. Do you think it's a binomial distribution or not? Well, I mean, obviously it is because I already began doing it that way. So you already know now. But why is it a binomial distribution? The first condition is being satisfied. A repeated experiment, a certain number of times it is being repeated, right? The second one, there are discrete outcomes. You can only either have a heads or a tails. The second outcome is being satisfied. The third outcome that is being satisfied is what? The third outcome here is the third condition here is success and failure. Obviously, we have a P and we have a Q, and yes, P, Q, and N are constants. There is no without replacement case in this kind of question. Moreover, doesn't matter how many times you're going to flip a coin, the probability for her obtaining a head is going to be 0.67. That's not changing. And if P is constant, then obviously Q in turn is going to be constant as well, right? Because like I said, Q directly depends upon P. So we have ourselves the entire thing, right? Now all that we've got to do is just apply the formula, and that is Px is equal to R is equal to NCR, PR, and QN minus R, right? Now look, I think it's better to keep on writing the formula over and over again as you're going to be attempting topical past paper questions, because I remember my teacher, Sir Jamil, all the way back in my O levels, he told me that it would be better if to write the formula over and over again just so that it can kind of stay in your head. And I know it's going to be irritating, it's going to be a bit aggravating, but at the end of the day, I mean, it's a win-win situation, right? So just to let it, how should I put it, sink deep into your mind, it's better to just, write the formula over and over again. Over here, it would be 5, right? because we need to find the probability of her obtaining a heads 5 times. Now look, this would be 15 C5, right? P is 0.67, 5 and 0.33, 15 minus 5, right? And this is going to be your answer. I do have my calculator on me, but I'm not going to waste my time, like plugging it all in. So you get it, right? Now there are other few cases as well. For example, the at least case, what what's that and more, right? So that would be in part 3. And I'll see you in the next lecture, inshallah ta'ala. Assalamu alaikum wa rahmatullahi wa barakatuh.